this video I'm going to just briefly describe the thing that I've been wanting to do at Variant for 3 years now, and I think continually confuses everyone, including myself. But it's been characterized as being as matrices, kind of this grand unification theory, kind of a way of masterminding everything. And I think that perhaps has some merit to it, but that's really not what it's completely about. It's more about finding a way to do things better and have just a better quality of life. But the problem is that after so much time has elapsed, there's two things really working against us. One is that there are so many different concepts involved in this that need to be sorted through. That some have merit, some don't have merit, some are in between. But we can't make up time and try to talk about all those things. So I'm going to keep touching on different topics that we're not going to all be on the same page with. So that makes it a little bit difficult. And the second part is actually an example of the first part, and that is in solution-based selling, one of the first things you have to do to a customer is inflict anxiety. So typically when you want to sell like an ERP system into an organization, they're not even aware of a lot of the problems they have. So solution-based selling tells you to go in and find the sore spots and elevate those so that management becomes aware of them, and then you create the anxiety, and then at the same time you create a rapport with them, so that when you do offer a solution, they're going to take that leap of faith and buy your product. And it's really a fairly genuine way of selling software, but it has that curious notion to it where you need to convince somebody they have a problem before you can propose a solution. And typically it's even worse because you have to dramatize the magnitude of the problem in order to be able to deliver a solution that is not dramatic. So that's kind of a paradox, and that's the case here, where it seems I spend most of my time trying to dramatize the complexity and the enormous impact that the problem, in this case that I'm going to talk about today, has, but yet presumably in my back pocket is a solution that's fairly straightforward and elegant in terms of being able to get our arms around it, but we never quite get there. And I fall in that trap, of course, all the time, as well as the organization has. So in this case, we've been working on this Base 2 project, and we've come across pretty much the same roadblocks, I guess, when we try to collaborate or work together when it comes down to the actual implementation. In other words, bridging the gap between something that's conceptual and actually writing code. Somewhere in there, there's just it starts breaking apart, and that's not to be unexpected. After 20 plus years of working solo, it's not surprising that there's going to be problems trying to find a way to establish boundaries and being able to get each person to really be able to work to their best. And I think we have the right people and we have the right situation. We just aren't all, I think, on the same page in terms of what this problem is, much less how to solve it, or at least how to work towards a solution. So I think this is another approach right now to trying to accomplish that. So in this case, we have we're trying to come up with a function to be able to import orders into Visual, and we're trying to sort out the boundaries in terms of what happens under different scenarios, and then who's responsible for those. It would be Andrew, myself, or Mike, and how do we best implement those with technology choices and not really being that terribly sure of what our requirements even are. So we're having a tough time trying to find a place to hang our hat, and at the same time I'm trying to improve the overall Variant process because I've done this a zillion times, and other than having deja vu, it's not really helping much. It's just teasing me enough to know that I've done this stuff many times before, but it doesn't really lend itself to a solution, just anxiety. So I really want to get past that, and I think that this is a way to do that. So let's just describe the problem a little bit more, first of all, so that we're kind of seeing the magnitude of it, because it is, on the surface level, fairly simple, and that's that we have an order with a header and lines underneath of it. Okay, so it could be multiple lines inside that header, and we're going to insert or update the whole order into the Visual database from an intermediate file. So the question becomes, just for purpose of this discussion, how do we handle this from an error standpoint? If we have 5 lines and 1 header, and we get 4 lines but 1 header successfully imported, do we consider that an overall success or an overall failure, or is it a partial? We say we have success on the header and we have 4 out of 5 success on the lines. So that is a question that doesn't have a right or wrong answer, but we do have to be clear on how we're going to execute this, both from a user standpoint, being able to support the product, and Andrew needs to know how to program it. And then, of course, it interplays with other things as well. So it's simple enough and on a surface level, and I think this is where I take the bait, just like I think other people do, where it just seems like something you can solve in your head in a few minutes and you just move forward. But it's just not that simple. Now let's talk about why. First of all, we're talking about a transaction boundary. So, is the boundary the individual lines? Is it the header and lines together, or what is it? So we're going to call that the transaction boundary. And then we want to know, how to implement it and where it's going to be implemented. So let's just talk about a non-integrated solution. First of all, we're just talking about creating this in a piece of software that doesn't talk to any other software. Just keep it really simple. And then we'll decide this boundary, or this method of implementing this boundary, and then what types of factors come in to making that decision. So I'm going to just draw some arrows coming into it. First of all, we have the business requirements. So this is going to be whatever it is that our customer wants, or what we want in our product. Okay, so this is going to be like, if you were taking orders and you were getting them over, let's say, the internet or something, you probably don't want to get 4 out of 5 lines. You want to have them all or nothing. Maybe not, maybe so, but you can decide what's important from a business standpoint, what you want to do. Maybe you want to get the other 4 and then you just deal with the 5th line as an exception. I don't know, but that would be at the business level of deciding. Some of the influencing factors there would be like the industry standards, what industry does, and then perhaps our client has something specific they want, right or wrong, but somehow this has to net out into a business requirement that drives that selection of how we're going to implement that boundary. Okay, then you have the visual architecture itself. And this is the way, as I like to phrase it, the same spirit and intention as Dave Lane had, the original architect, and when he designed the software. How did he view that? Okay, and the influences are there, is that sometimes it's just bad Dave. He just made a bad choice, and we don't always agree with him. So, do we go with what he did, or do we try to do something better? That doesn't happen too often, but it does happen. What happens quite often, though, is inconsistencies. In one module, it will do it one way. In another module, it'll do it a different way, and it may or may not be for legitimate business reasons. So, if there's different business reasons, that comes to play over here. But the inconsistencies are really difficult to reconcile over here. But we still want to be able to play and work well with the visual application itself, of course, particularly since that's what people expect us to be mimicking. It essentially is the visual software itself. Then we have the implementation, and this one gets a little bit more elusive because this is how we're going to actually handle things. So, and this gets a little techy, but it'd be something like optimistic versus pessimistic. So optimistic would say, we're going to assume everything went well over here unless we tell you otherwise, or unless something happens. So we're going to assume that all the lines came in. Pessimistic would be that we're going to assume that nothing worked unless we have a confirmation that it worked. So this would be like the ATM teller, where you don't commit to taking the money out of your account until the entire transaction has been verified that it went both ways. So the money comes out of the bank cash account and also comes out of your account, but not one or the other. So that's a pessimistic system, to where it's going to roll back unless it has confirmation that it worked. So that's kind of an implementation choice that is tied into this, of course, and tied into this, but really is something that now is getting into our architecture, and we're deciding how we philosophically want to approach the problem. Some other implementation things here could be like, where's the best place to do some of this stuff? Is it right in a function? Is it, in a like a wrapper that goes around something that Visual wrote, and we're just going to augment that? Is it going to be in the database? Is it going to be in the application? Is it going to be as a class, all those kinds of things are all implementation decisions that, like again, interplay here, but they're somewhat a separate path. And some of the influences here are that we just don't know. They're unknowns. We don't know all the stuff. We have to learn it before we can even decide that, but we can't learn everything. And another one would be just, you have to sometimes guess, because we don't know necessarily if the optimistic or the pessimistic is going to work until we get into a bigger picture of what that really means. And then the fourth big influencer, I think, is the technology itself. So that would be, are we using SQL Server, stored procedures? If so, version 2005 or 2000. That was a big gotcha for a while. Are we doing Team Developer 1.5? Are we doing ADO, Visual Basic? What's the implementation technology over there? And that's going to then, of course, narrow the playing field and constrain what kind of implementation choices we have depending on what's over here, and vice versa. So it gets to be a little bit convoluted because visual also involves different technologies and implementation strategies depending on which module. So something over here changing certainly can change things over here. We would like to believe that this is kind of the absolute where we can hang our hat, but realistically that's a negotiable area as well. And the clients really see value in that. So one of our value propositions is not to be hard-nosed and go in there and say that, we're going to do this from a top down, that we're going to, you ask for A and we're just going to, no matter what, make A happen. It's really to negotiate this to make a cost delivery viable based on how we can optimize the decisions in here to make this more agreeable to the customers. That's a really big value proposition for us. So you can see right away this gets to be fairly complicated, and they all interplay with one another. So it's tough to come up here and just say from a 10,000 foot view that we're going to do this and this and this and this, and then be able to stick with it without having, you hit your toes on something, or without being extremely rigid when something over here changes or what have you. Now let's make this a little bit more complicated, because as you noted up here, we had the different versions of SQL. Well, of course, you got the different versions of visual as well. So, how far do we want to go with that? And we have different, if we have different clients for like products, we have different interpretations of how these business requirements should work. So that gets a little complicated as well. Visual also splinters off because not only does it have versions, but it also has different configurations. Are you in standard cost? Are you in actual cost? Do you do FIFO layering in your warehouses, or do you not? Things like that profoundly impact the way transactions are handled in the workflow. So those are configuration choices, all within different versions of visual. And then you also have a platform considerations. Are you running on SQL Server? Are you running on Gupta? Or are you running Oracle? Which influences this, although interestingly enough, it also influences this, because some of the stuff can't be done in one of the technologies versus the others. So they actually have to rethink the optimistic versus pessimistic strategy. So that's not even a universal implementation because of the constraints of, for example, the AS400. And then lastly, another variation we have out here is the localization or culture, what's called localization stuff, where we don't get a lot into that, but if you're working in different currencies, different languages, even different cultures, it does come into play, like sales taxes versus sales tax versus value-added tax, things like that. Again, profoundly change transactions, and in a sense, change some of this stuff as well, depending on how far those transactions spread in the system. Okay, so these are the kind of factors that come into play. Now, let's be realistic, because this is just putting something into one system. Now let's see what that looks like when we actually do an integration project. So we're going to have the visual piece over here, and I don't know if I can draw all this. We're going to have the technology thing coming in, implementation, and we're going to have business. Can't even read this, can you? And over here is going to be the visual influencers. So this is going to be our method choice. And this system here, let's just say, is visual. And then we're going to have a system over here that is our third-party integrated solution, and the same diagram is going to be in here. So I'm not going to draw all that up. And then we're going to have another piece of software here, most likely, at least one, if not more, some type of middleware. And it's going to need its own methods of doing things. So that's going to have to be in here. And of course, it has its own technology. It has its own implementation. It has its own, I guess, business requirements, but not maybe quite so much. But it certainly has its own native characteristics of how it's designed and behaves. Okay, so now we've got these chunks sitting here, and like I said, there could really be more chunks than just this, and realistically there are, because even within Visual, if you think about it, there's the application and there's the database at a minimum. So you have two different things going on there playing, because this method would be impacted by one or the other. It doesn't matter which one it is. So what we end up with here is bringing out the business influencers into kind of this common pool here, where we're going to come up with some kind of unifying theory. Say that based on the constraints and capabilities of what we're trying to do from a business requirement standpoint and capabilities, we're going to come up with something that's realistic. So maybe with all these technologies put together, as it sits right now, perhaps the lowest common denominator is that there is no way for us to deal with individual order lines at a granular transaction level, just for whatever reason. So we may have to say that we have to deal with an order in whole. And that constraint might be this system over here, for example, which would be a given in this case, so we're not going to change that. But maybe it's the middleware that we chose that's doing that. So we certainly want to know that, because that middleware can certainly be swapped out with a different flavor up here if we need to. We don't want to have this get overly complicated, but we're not going to put a constraint on our overall requirements of the entire project just because we're shy of changing out that middleware or challenging what's there. So these influencers go all the way across the board, and like I say, I have to come into this unifying theory down here from a business standpoint, and then the other one that has to come down is the implementation. So, and that's probably the biggest one. So how do you implement this of all the different choices in there? How do you implement it of all the different ways of doing things here and here? How are you best going to implement the strategy of this transaction boundary? Okay, now let's drill into this one level deeper before we start talking about a proposed solution. This is kind of the integration touch points, the integration architecture, and the influencers of trying to decide how to define a transaction boundary, or what a transaction is, if you'll recall. Now let's go into a deeper level where we're actually going to write some chunk of code. So let's just say it's a function or whatever it might be. It's just some coded chunk that's just sitting out here. And we want to write that, but first of all, we want to be able to have someone own it and be able to apply their talents and so on to it, and not feel like they're just being an order taker or a button pusher. So we need to be able to have good boundaries in our organization in order so we can have good boundaries in our software. And that is not always as easy as it seems, because there really is a little bit more to it than you might think. And again, this is where we're a little disadvantaged, because I wanted to at one point talk about solution-based modeling, which really defines planes of software in terms of the way you develop it. So if you think of just horizontal planes, there's a conceptual plane. How do you spell conceptual? Conceptual plane. There is a business plane. There is an implementation plane. And there is a technology plane, which is very similar to what I was just talking about. But basically it's saying at the very high level is kind of your conceptual architectural view. Like, we want to have a very tall, shiny building that has, looks like very modern. So that would be something very conceptual. Business would be that it needs to be able to accommodate 250,000 square feet of this, and has to have so much electricity, things like that, in order to support the business needs. The implementation would be more of, what types of materials are you going to use, when are you going to build it, where are you going to build it, that kind of stuff. And the technology becomes, right down to what kind of fasteners you're going to use and what type, brand name of windows, all the way, down to that level of detail. So they all come into play as well, because those are really the horizontal influencers that come into this decision. But in reality, they are stacked planes that cross over in like this matrix format into the other things we were talking about. So it gets to be kind of confusing with all the different interplay interactions that are going on. Now let's make it a little bit more confusing, because this code chunk, from its perspective, if you think about it, it's going to just be some engine here. I can't draw an engine, but it's going to be some kind of engine that ingests data and then outputs data of some sort. So you're going to have data in and data out. Essentially what most of our functions do. The question is, where does this data come from? It could come from a flat file. It could come from a database. It could come directly from a GUI object, like you select a combo box or something, or a little table in the window. It can come from parameters or something in memory being passed to it. It can come from a Windows message handler. And there's probably more. Same thing on the output. The output can go to a flat file, it can go to the database, the GUI, all the way down the line. So you end up with an awful lot of permutations going on there. And what we tend to do is have this kind of hodgepodge mix match. So, and then we wonder why we have problems, because something maybe fetched out of the database, and then we find something else that's in a table in memory, so we fetch that, but don't realize that those two may not always be synchronized unless the save button is pressed, or something of that nature, or might be some kind of multi-user concurrency thing that we would never detect unless you understood the architecture of the overall software. So you get into all sorts of record-locking technology implementation things that you didn't intend to, just when you're making a choice here. So these are critical choices from an architectural standpoint, but it's something that we can't have that debate every time we write a function, which is what we do at Varant, because either we just make assumptions, or we try to oversimplify, or we try to over-dramatize. Whatever we try to do, this doesn't really get resolved. It just kind of happens out each time, and we either have luck or we don't have luck, and it's just a very difficult path for me to keep going down, because it's not only a school of hard knocks, but it's just totally unnecessary, and it's a lot of liability, and it just tends to derail almost every single project at some point, because it's just discouraging to have something small like this come into play, and then you have to have that same internal debate, at least in my mind, in terms of what's the right way to do something, so that we can have some kind of consistency, some kind of standard. And there really isn't a right answer, again, but there certainly is ways to wrestle this, because this is a problem that has plagued the software industry for years, just because it's such a renegade, do-it-yourself proposition that is anything but more simple as software evolves. It gets actually worse in my opinion. But anyway, the other thing going on here is you have something that is calling this function, whatever it might be, and then it returns something back in terms of a status, saying I did it or I didn't do it, or why I didn't do it, or what went wrong, independent of this data coming in and out. And even there, we have all sorts of different issues going on. This could be something as simple as just like what I would call a niladic call, where you just say, go do this, and it just does everything on its own. It can be a monadic call, where you say, go do it, and you tell it what thing to do it to. So you could say, the first one could be like import all pending orders. The second one could be import order number 175, so you tell it which one to do it. And then a third way of doing that would be something that's contextual, where it's say import the order that's currently on the up on the window, on the screen. Or it could be loop through all of the orders that are currently loaded into a cursor from some other function. And that's a pretty common thing. But that is also really slippery and difficult to share things when you're expecting a stateful interface, where not only does these elements have to physically be in place, but you're now assuming that we're in some particular state. That is, we're in a loop that is going through a bunch of data elements pointing to the database that can be dynamic in nature, but it has a pointer, a cursor, that's looping through them in real time, and you have to assume that you know how to play with that cursor as it's looping. And it's a fairly straightforward thing to do, but it's not if you weren't the one who wrote the cursor who you're trying to interface to. So those are the kind of complexities going on there. And then over here on the return side, it gets to be a little bit even slipperier. At a basic level, it's just returning yes, I did it, or no, I didn't. But remember, there's different levels of that. That means, did I actually execute regardless of what I did to the data? That's really what that first one would mean. It's just, did you execute or not execute? And then, of course, did you have any errors with the data? And then you end up with all these different scenarios. Well, what do I do about errors? How do I handle them? Do I roll them back? And we're going back to the transaction boundary, but we also then have to decide what kind of debugging information is going to be available, and all this other kind of stuff. And that is really just a great deal of housekeeping that can just be a matter of standard policy and a standard library, and we don't have to reinvent that over and over again, because you just need to have a log file, an audit trail, a debug function, all the basic stuff, and there's really no reason to rethink all that. We just need to come up with that strategy. Same way on the call kind of side, where there's no reason to not narrow that landscape, but that's really the general topic overall here, is that we need to narrow the landscape on everything, but at the same time we need to broaden our horizons so that we're not so boxed in, and that's kind of the paradox of this. What I want for a solution, because I think when you're defining a problem, you have to define what it is that you want for an answer before you can even ask the question. So what I'm looking for is some type of self-evolving guidance, best practices, something that is going to be on paper, but is not going to be overly, complicated or voluminous in terms of marching orders, but something that's going to be of actual help. So that means it would need to be written by whoever's going to use it, so that we're not trying to tell people what they want to hear, but we're actually giving them the information that they need, and then they're documenting that so that it's in their own words and meets their own needs. So for me, that would be, some best practices. Maybe we would say we want granular functions that only do one particular thing at a time. If you're going to do order lines and order headers and loop, then you should really have 3 functions that are nested inside of each other. That could be a rule of thumb. This is the first function down here creates a line, as in one order line, and then this one up here creates the order header, and then calls this one, X or N number of times for each one of the lines, and then up here would be a loop thing, which would be the orders processor, which would then call this however many times it needs to for how many orders there are. That could be then a policy saying we don't want to mush all this into one function, we want to keep them separate, and then we may say that it makes sense that these functions get their data, that input part, directly from the database and output to the database. So DB in, DB out. At each level, they don't try to say, we're going to pass information down. Now, how do they get called? Remember we had that calling function? Well, maybe the policy here is we don't want to get to be too esoteric or too many different ways of calling this, because you could pass something to it. You certainly could use the database to have each one of those functions find out what it's supposed to do next. You could use messaging, all sorts of different things, but we should probably pick one and say that the way we want to do that is parameterized function calls. And that way, this line function gets called by this guy, who then says, call the line function for order number so-and-so, line number so-and-so, right in that call line. That would then just be a best practice. We don't necessarily have to always do it that way, but we would do it that way unless there's some compelling reason to not do it that way. So that narrows the landscape on just things that really don't matter that much, because I don't know that anybody's that emotional about how to call functions, but it gets to be really confusing when you've got all different things going on. And if you think of the Lily code, it's even worse, because they got stuff like they're using stacks in between, where they shove things off into a memory stack, and you have to be able to peel them off in the right order and sequence, and then parse them to be able to get them to go to the next function, and it's just ridiculous. But that is another scenario, and that we haven't even talked about yet, but that would be how to resolve those discrepancies in code reuse or in trying to mimic visual behavior. Do we just bite the bullet and do it the way Lily does it, or do we try to reinvent the wheel and improve it because it really sucks the way they're doing it? So like the stack thing, do we just code around that and say we're going to do it in a more systematic way, maybe using an array or something, or a table? Or do we try to learn it their way and cobble around it? And there just really isn't any good answer to that one. But the answer we have right now is to just hope for the best is just really not acceptable at all. So the way that I would get on top of this and to be able to generate some of these best practices, that could be like one best practice. Two could be more of a less techie thing, could be more of a business plane. And I think this is, this to me is maybe like almost an Andrew kind of decision, because it's really a stylistic kind of thing in the code writing itself, kind of the way you like to do things. I don't think anybody much cares how that's done other than the programmer. But a second best practice could be, where do we best have touch points? Are they back here in this diagram? Are the touch points between systems? I don't really have that drawn up, I guess, but between systems, is it at the database level? Is it passing data back and forth through an intermediate file? Is it passing it back and forth through some kind of messaging, like the BDC visual integration? Where does that touch point take place? Or is it at the application level itself, where the two programs are talking to one another? Enterprise application integration. There's different ways of doing that. You could also do the hub and spoke approach, where there's a piece of middleware that marshals data interchange going back and forth, kind of like the Visual Exchange package does, that we've dabbled with but we've never actually done. Or there's the data junction way, which is even much more robust and diverse hub and spoke, but it does multiple stages of hub and spoke. So you actually go through 2 or 3 hops, I guess, between systems, but it would do it in a very systematic way so that you're always following a standard transform path and not trying to customize anything. It's a pretty cool way of doing it, but we really kind of abandoned that a couple of years ago too, unfortunately. My point, though, is that all those are good choices. We probably narrowed the landscape only because things have just fallen by the wayside because of the passage of time or just of circumstances of what people have wanted from a client standpoint, but it certainly has not been strategic. So I think it makes sense to actually broaden the field, at least for a short while, and revisit some of those things, like the data junction and all that, because some of those things really were good strategies, and to abandon them is kind of silly, and I'm not so convinced that the latest and greatest is always the best. So I think that's one way of doing it, and the other way is to see where we've had the best success. So this all kind of comes down to just a business practical matter, and we can come up with a very long-winded way of getting to number 2 here, but that would be, we could say, Verant seems to do best when we hook database to database. So we don't try to go with the hub and spoke. We don't try to write a Visual Basic program. We don't try to have the order management software, for example, application reach out and somehow work on the data over in BDC directly. We don't do those kinds of crossovers. What we do is just have stored procedures and triggers that go directly from database to database. That perhaps, I'm not saying that's a strategy we would have, but that would be perhaps something we could propose for number 2, and then say that would be our first choice, second choice, third choice, and then maybe have some criteria on there to guide us so that when we look at a project, we could have a way to kind of systematically narrow the landscape from a broader landscape than we do now, but be able to get down to something specific fairly quickly based on evidence, based on best practices. So that's kind of the thing that I'm looking for a solution. And again, this could be something that is driven by specific criteria. You could actually have questions that you would ask here to say, if these things are going on, then we want to go with this strategy, and so on and so forth. So I won't come up with any examples there. I won't make this way too long. Okay, now how do we go from the previous blizzard of arrows and criteria and things that are influencing decisions and confusion to this kind of a solution to where we can actually get back and do some work, and we aren't going to get caught in the quagmire of trying to improve Brandt processes and not ever actually write software for money. Well, my idea is so the idea that I've had for this is, I think, the same way I would approach any of these types of problems. And the words I've used in the past would be like a place to put my stuff, a matrix, the Socratic method of self-discovery, agile, grand unification, all these kinds of things I think come into play, but we've never really seen what that means. And I think it's a bit of a trap because I'm trying to solve my own problem, and that can't be done. So I need to really have help with certain aspects of it, but we have to be careful that we don't try to strong arm this, because the idea here is not just to get resolved and get tough, nor is it to get wishy-washy. It's to get focused on a strategy and a technique to nibble away at this problem. This problem is not going to be solved. This problem is not going to go away. It just needs to get a better and better solution to it as time goes forward. So it needs to get evolutionary. That means it needs to have a system in place to make it kind of work on its own, but it needs to be not implemented by me nor managed by me. I can certainly design the system, the architecture of how we're going to design architectures, but I can't manage it, nor can I do the physical implementation, because I'm going to get trapped in that part of it. But that doesn't mean that we have to all be in this confusing nightmare. The idea is that by putting a system in place, that I will be able to spend more time than really weighing the more, I guess, what I'll say, profound decisions that need to be made, like which is the better way of doing locking, optimistic or pessimistic. If I can focus on those kinds of choices without having to constantly have deja vu and be thinking about what that means from a very specific and very general standpoint on projects that we're working on, that's what derails me, because either I'm way down in the minutia or I'm way up in the clouds on the specific instances of what we're doing at the time, and it's really difficult then to just struggle with the more profound questions and come up with a strategic best answer. But I think I could really do that if we had these matrices in place to put my stuff in the Socratic method and all this kind of junk. So what that means is just really a bunch of lists and places to put my stuff. So one thing would be like integration type. If you think about the stuff that was on these charts that I just drew, we have integration type would be a database to database. We would have a hub and spoke. We would have application integration. We would have spaghetti junction, where just everything hooks to everything. You have point to point. This list would evolve and would get more specific, it would get more general, it would collapse, it would morph. So when I say I want to add this or start this list, it'll have a couple of things in there. And maybe 6 months from now, I'll say, well, I never really thought that, the multiple hub and spoke staging approach where you have 3 or 4 hops was even an option, so I'm going to add that. So I'll add that in there. And then maybe 6 months later, I realize, well, that's really the same as this. We'll take it back off and just rename this. But that's a viable way of evolving this list in terms of our choices, with the goal being that we're going to have information out here that says, here's what that means, here's how that plays out of Varant, and how successful have we been based on real evidence on those types of things. And then I think because of that, if you can imagine, some of these are going to become just lifted off the page. You'll start saying that, this one just makes the best sense for Varant, and this one just really doesn't make very good sense. And again, that will evolve, and it doesn't mean something comes off the list, because we still may need to have the other choices, but it's going to narrow the landscape in a scientific way. Now, this may spawn off, because there might be something here, well, it's not so much hub and spoke database to database as it is the methodology that it be hooked together, the mechanism, how they talk to each other. That's really more important to me. And that's kind of implied here because the hub and spoke system that we use, Data Junction, has its own mechanisms built in and so on, but I realized maybe 12 months into this that I need to have a transport mechanism list. I'm going to call it transport mechanism list. And then I'll say, okay, that means you've got like an intermediate file. You've got a in-memory transfer. You have a intermediate database, something like that. And then maybe a month after that, Andrew points out to me that that has nothing to do with transport mechanisms. Those are data structures. So I thought, okay, well, the concept is good. I just had the title wrong, so I need to rename my list to be something else. And I'll come up with that name. We can call it Moose, but it's still, this concept is still good, except for maybe one of them doesn't even make sense at all. And then that comes out somewhere else. So this kind of evolves, and I think that is something that is both good and disastrous, depending on how it gets used. If we let this run amok, like I will let it run amok for sure, if I get too involved in how we label these things and what we call stuff and lose the intent of trying to use this as a way to harness our problem, then it's going to become its own life form. There's no doubt about it. But if we come in here and absolutely say that, because we called it a transport mechanism, it's going to be called that forever and a day because we're just stubborn, then we've really done ourselves a disservice, because by honing in the word choices and so on, that means we're honing in our understanding of what we're trying to do here, and this gets to be an elegant simplicity then. So it's really that combination of all of us working together and people just having that eureka, yaha moment, moment where someone says, that was really not at all what that is, or you wake up and you realize that 5 of the different things on here really are one and the same, or are irrelevant, or what have you. Those are the kind of things that make all of this worthwhile, because you can take a big leap forward and all of a sudden it's like a big weight off your shoulders, and we can actually do something without being held down by the baggage, with confidence that we're doing it in a productive way that's not going to come back and bite us in the ass, like most of our stuff does when we work on collaborative integration stuff. So that's kind of the place to put my stuff. It's not necessarily just lists. It can also be things like just documentation. So if we have a list called technologies, you would certainly want to have that. It would be SQL Server. You can have your Gupta, Team Developer, Visual Basic, all the way down here, WinBatch. Everything would go in here, and then we would want to break that off probably and have the different flavors, 2005 and so on. And this is where we need to have a librarian type person, because if we start putting comments in here about, this is a really great way to import orders, is to use SQL Server. Well, SQL Server doesn't really mean anything, so we have to say SQL Server, oh, you mean stored procedures. Okay, great. That's a great way of doing that. But do you mean for 2000, 2005, or 2008? Well, it doesn't matter. So, but this is where it gets to be unwieldy, because you can't put that comment on all 3 of these. You want to put it at just this level, but then there's going to be this tribal knowledge that really makes this whole thing become powerful, because we'll come across something like I did at Trust Build a couple of months ago, where I needed to have a line of SQL get executed as a literal math string. So it was like 23x 25. I didn't want it to be a text string. I want it to be 23 times 25. And there's a function that does that in SQL Server, and they took it away in 2005 because it was considered a security risk. It took me like, days to write this bloody function of picking that apart and substituting characters in there and actually building a math formula, whereas in 2000, it was like a 6-second implementation. I would like to remember that, because I won't remember that a year from now. I'll just have deja vu knowing that there was something about something on SQL Server and about something with executing something. But I would have enough to where I'd have anxiety and keep things from moving forward, or run head on into the collision for no reason. So I would want to put that somewhere, but to put it at the stored procedure level doesn't make sense, or at the SQL Server level. It needs to go into this particular flavor, again, without making this to be the project of the century. But if we don't have that kind of capability, then there is no point. So that's where the librarian needs to come in here and be able to draw some practical lines in the sand and say that, yeah, we got to have some kind of structure that allows us to be able to have comments apply to all versions versus one version without having to retype them and all that, but we can't get so carried away that this thing just sinks under bloat. And that is not to be me. I can just tell you what I need, and I just did. So that's would be the function of the librarian, and they have to be willing to realize that this is going to change. Someday we may just say that, or in Microsoft's great fashion, they rename things like every other day, so all of a sudden store procedures may be called something completely different, even though they're the same. So we're going to want to have some way to accommodate that so that we have that semantic disconnect resolved. And if it's exactly the same, we'd like to know that and not have it as a whole different branch coming off this. Or if it's exactly the same but just slightly different, that too is important to know. And a great example of that would be between technologies. A stored procedure in SQL Server and a stored procedure in Gupta SQL base are very similar, but they have a completely different syntax. But functionally, they're almost identical. So to be able to understand that difference, if we were to do a lot of those types of dual technologies, which we used to do, that would save just a boatload of time and frustration to be able to have those kinds of rules and nuggets, I guess, of wisdom of how to do things like that. That's the librarian function, and then the other role that really is important to complement what I'm trying to do would be, the voice of differential or the opposing voice just for opposing sake, and that would be to constantly challenge some of these things that I'm talking about, not to be stubborn and not to be obstructionist, but to be differential, so that we're challenging things all the time, and we're not just making things going in a direction just because that's the way my mind happens to be thinking at the time. I really want that different perspective to come into play, and the best way to do that is to have people from different planes, going back to the business plane, the conceptual plane, implementation, so on. That's when you have that crossover in this vertical. That's when you really get the power of the organization, because and I feel like that's where I bring the best value, because I could reconcile something that's way down at the bare silicon level. Maybe Andrew's writing a function and trying to decide what kind of Windows message to use. But up at the highest plane, the customer wants something that Mike's dealing with them, and we need to somehow come up with a strategy in between that's going to mediate that, or come up with a way to implement a solution that accommodates both those. And that's the kind of stuff I love to work on. But again, not if I have the forest and trees conundrum constantly badgering me. So I need to be able to draw upon this when I need that kind of detail, draw upon this when I need that kind of information, and then I can look at the demand versus how to supply it, balance that, come up with a proposed solution. But that's where this other role comes in. I want to have that differential against somebody who can make sure that this is a wise choice from the get-go, so that we can maybe jump, because this is going to be a series of approximations, but if we can jump 4 or 5 approximations from the get-go, we're all going to be better off for it. And that doesn't have to be a long owner's process, but it certainly can be a it can have a great payoff very, very quickly, and I think be infectious in terms of just having satisfaction that in a small amount of time that we jumped way ahead on the project. So again, this differential takes place not so much lateral. We don't need another one of me. We need to have the differential taking place with different mindsets. So someone who is really techie, somebody who maybe doesn't understand the software at all would be useful. Somebody who understands visual but doesn't have a clue what we're doing would be useful. Somebody who understands business but hasn't got a clue what we're doing would be useful. So you could have these different dimensions out here, from the user, just business in general. Over here was what? Visual in general, and down here is technology. That would make a great differential. And then from that, we would be able to take this information, draw it in, come up with a conclusion, and then push that latest kind of approximation towards a solution, or latest wisdom, back out into all these different places where I've got stuff stuck. So again, like a list of integration, list of technologies. Those are the kind of the nouns. The lists that we would need for the verb part of it is going to be, what do we style after? If we're doing how do you spell style? Style. If we're going to do, in this case, the base 2 integration, what do we mimic our software to behave like? We'd want to mimic something because we are doing integration. So obviously, VMDI. We want to look and feel and run like VMDI. People shouldn't even have to pick up a user guide because whatever VMDI does, we should do as best as we can. Is that practical? I don't know, but that would be a great starting point. So, a rule of thumb for the style after could be that we try to align the implementation with the system of choice. I don't know. And if you're doing integration with 2 systems, which one do you mimic then? Maybe it should be mimicking base 2. So there's a good question. See, I wouldn't even thought of that. But this list then could have kind of those choices. And then from that we derive some best practices. If it's a product, maybe we want to just say it's not important at all to mimic visual. We want to really just do it right to be breakthrough. Or is it more important to mimic a similar window? Because for years that was a selling point of our software. They looked the same, smelled the same, tasted the same, installed the same. There wasn't any kind of learning curve or any type of environmental change. That was a selling point, even if the interface and the functionality was less than ideal. But that was a strategy from over a decade ago. So I'm not so sure that plays out anymore, but maybe it does. So that would be the style after list. The chunkification list gets a little bit more esoteric here, but what is a chunk? We talked before about the functions. Do you have a function that is a real low-level thing to create an order line? Is it to create an entire order? That kind of thing. But going beyond that is defining the other things that were in that chart, wherever that thing went here. The code chunk, defining what kind of data in, data out policy we should have, where we should really be putting our focus, what we should be not doing. We should maybe just not even do this. Maybe we should not even do this. This is not a good idea, so we shouldn't be doing that unless we absolutely have to, and then we should really justify why, so on. So that would be kind of the chunkification, and then that would lead, so this is kind of a best practices, but that would then lead to a very powerful list, which would be the chunk history, I guess. Again, I don't have necessarily words for these things, but it would be all the things that we have done in the past with some type of opinion on it. So this could be at a project level, certainly, where we'd say we did an integration into some kind of CAD system, but I think we kind of know that, so we'll still develop some kind of project history out here. But this would be a level below that. So if that integration involved creating an invoice, for example, then I would want to be able to have in this chunk history invoice creation or invoice import. And here the word choice is going to be really important because that's going to classify what it is that we actually did. And I'm not so sure we always know what we do. At least when we talk in common, so I think that's part of the breakdown. But we would come in here and have that chunk history and then be able to classify it, and that other list would be probably the more important part, where you'd say, okay, is it an import? Is it a creation? Is it an update? What are types of things that we do? So invoice creation would actually mean it imports invoices, it updates invoices, blah, blah, blah. So we somehow figure out what it is that it's doing and try to cross over that business and implementation plane area. So we're trying to say that this is an invoice from the standpoint of a business turnkey solution. We're not just talking about 3 or 4 fields, but we're talking about the entire invoice and all the things that implies. So that's a big part of this. Let me just talk about that a second. So there's a difference between a shipper as a single programming element and a shipper from a business standpoint. If we're talking about implementing a shipper, that's pretty simple. It's a header and a bunch of lines, maybe a delivery schedule that's in 3 tables, and that's it. If we're talking a shipper from a business plane standpoint, then that means a shipper and an inventory transaction that is against inventory warehouses and against the perpetual inventory system and flows into cost accounting. and all the FIFO and actual costing and all those types of layers. All that is implied because you don't ship something unless you actually take it out of inventory and cost it, and then also, as another path to that, then prepare the information to go into an invoice and generate the revenue part of the general ledger. So there's all sorts of implications of what it means to be a shipper from a business standpoint. So that's what's so important here, is really trying to classify this, and I think this is that part of that process where we would say that, so what was the intent of this particular chunk or this particular module? Was it just to do a programmatic task of creating an invoice, or was it to create an invoice, with the bigger I on it in terms of a business standpoint, and do all that would be necessary both from a business and from a visual software architecture, all those things necessary to make that work. So that would then kind of frame what we've done. And then from that we can say, here's how we did it, and what technology, and then briefly have any kind of just like lessons learned or anything. It doesn't have to be a novel, and really can't be a novel, but I think 10 minutes doing that every time we write something, and maybe even spending a few days or even a week or two doing the history of these things and chunkifying it, is going to be an enormous learning experience for the organization. Just trying to go through the exercise I'm talking about right now of chunkifying and classifying and categorizing it, as long as we don't get carried away with it, is enormously fruitful in terms of understanding what we're trying to do and what the problem is that we're really trying to solve. So this part is an important part both for the librarian and for the cross-functional team to challenge this, because I look at it one way, and it really needs to be looked at from a variety of ways, and some of that is just getting distance, but it does not mean this just needs to be strong-armed or just slam-dunked. That's not the intent. There's no reason to do it if we do it that way. And we certainly can have a different methodology for going after this, but we can't have debates about that forever either, because remember, we're already one step level back abstract now, because we're trying to abstract our way of writing software, which is a way of doing something. So we really don't need to have a challenge to the way that we're doing our analysis of the way that we're going to write software that does something. It gets to be just a little bit convoluted for all of us. So this is the approach that I've been wanting to use, and I think it makes sense. And but it needs to be measured and certainly gauged in terms of the number of hours we put into it, and does it have payoff? I really strongly think it will, and it just makes good sense that it's going to put some science behind what we're doing. So the module history, the chunk history, the classification, so on, and then the tribal knowledge, this lessons learned stuff permeates all of this, I think. Whether it's literally put in here as text, as information, or if it's just the combination of the actual data itself being manipulated and refined and twisted and turned, that kind of gestalt of all of this coming together, just the way we form it over the years or over the months, that in itself really becomes tribal knowledge and will guide what we're doing. So that's really it. That's how I would solve a problem of, in this case, specifically a transaction boundary within one application that is part of an integration effort. But as you can see, really, all of these tables and the strategy had nothing to do with the transaction boundary itself. The strategy would work for most of the technical challenges that we have. So I think this is a really good kind of overall methodology for grappling with our founder syndrome and trying to get a value proposition out of a lot of weeds.